This video is going to show you different ways of looking at a data set where I have units. So for example, I have distance traveled for an upcoming break for statistics and art students, and this is in miles. This type of data is called quantitative data. And I'm going to be showing you the two ways of kind of going through this process to test if there's a difference in average. So one way is I can do a two-sample t-test where I compare the first average, statistics, and the second average, art. An alternative hypothesis, I will test if they're not the same. The other method I have, besides using a t-test, is analysis of variation. I can use ANOVA. My null hypothesis for ANOVA is always that the averages are equal. The alternative is typically that at least one average is different, but if I only have two groups, then my alternative hypothesis ends up being the same. So I'm going to be analyzing the same sort of set of hypotheses here using very, very different models. I'm going to do just a tiny bit of prep work to see what's going on. So in my calculator, I've cheated a little bit. I've gone ahead and I've typed in all of my statistics data in list 1. In list 2, I've typed in art. And in list 3, I typed in all of the values, like one massive list there. So if I do stat, calculate, and 1var stats, and I have a video up that shows you how to calculate 1var stats for lists. In list 1, I had all of my statistics, and it had an average of 53.33 repeating, a standard deviation of 27.08 or so, and 12 samples. For the second group, they had an average of 47.5. Units are miles. You should really write down the units somewhere so you don't forget them. Standard deviation was 25.19. And my N was 10. And finally, if I were to type everything into my calculator and find an overall average, this overall average should be somewhere between 47.5 and 53.33 repeating, because it's the average of all of the values. When I do this, I get an overall average of 50.68 or so. Okay, again, I want to show you the two different ways of kind of going through this problem. Let's start with the two-sample t-test process. The model for a two-sample t-test says first average minus second average should follow a t-distribution with some degree of freedom. Your average difference should be 0. This is saying that if I took the first group minus the second group, I don't tell the difference between them. Your standard deviation will be the first standard deviation squared over the number of samples plus the second standard deviation squared over the number of samples. I'll fill in the numbers in a second, but I'm just rewriting down the model. My third step will be the p-value, where I actually compare those two sample averages, or more extreme, whatever that setup's going to look like. And my final step will be my conclusion. Let's come up with the model. There's a claimed difference of 0 between the groups. I think they're the same. I'm plugging in my standard deviation 27.08 squared. That was for 12 samples. I'm plugging in my other standard deviation of 25.19 squared. That was for 10 samples. I'm square rooting that number. So I've got the square root 27.08 squared over 12 and 25.19 squared over 10. I'm not going crazy with parentheses. Order of operations does a lot of this for me. I get 11.16. As a rough estimate, I tend to use the smaller of the two degrees of freedom. So this would have a degree of freedom of 9. This would have a degree of freedom of 11. My smaller of the two groups would give me a degree of freedom of 9. I'll actually show you what this is using technology at the end, but just as a rough estimate, you can take the smaller of the two groups and base the DF off of that smaller of the two groups. This is essentially assuming that you are as strong as your weakest group. So for p-value, my alternative hypothesis, I'm testing for a difference. My first average was this 53.3 repeating number. My second average was this 47.5 number. So this gives me a sample difference in averages of, well, let's type this in and see what we get. 5.83 or so. This is not my p-value. This is the value that I'm going to put onto the curve. Center of my curve is 0. I'm counting by 11.16 or so. My value is 5.8, so that's somewhere about here. And I'm testing for a difference, so this is going to be a two-tailed test. So I'm going to shade out and shade out. Looks like a really large p-value. That's okay. I'm going to find my t-score by taking my value minus the center of my curve divided by my standard deviation. This gives me a t-score of 0.522 or so. To look this up in my calculator, my p-value is going to be 2 times this right tail, or 2 times this left tail, either one. So 2 times my t-CDF. My right tail starts at a t-score of 0.522. It goes on forever, so it goes on to infinity. And my degree of freedom, as a rough estimate, I'm calling it 9. So 2 times t-CDF, I'm doing second vars on my 84. I can also find the student t distribution inside of GeoGebra by going into probability and choosing student distribution. I can find this in my TI-89 by going into stat list editor and choosing F5 for distribution. I'm typing in my low value, my high value, my degree of freedom. I have the 2 times built in. When I do this, I get a massive p-value of 0.614 or so. I want to double check this using my calculator. Just to see what my calculator gives me for my t-score and my p-value to see how close my by hand and technology results are. So I'm going into stat and then test, and I'm doing a TwoSample Ttest, and I have all of the data typed in my list 1 and list 2. I'm testing for a difference. There's a video on how to do TwoSample Ttest in your calculator up already. This gives me a t-score of 0.522 or so, 3 if I round a little different. It gives me a p-value of 0.61, 0.61, pretty dang reasonable. So my results are really, really comparable. I'm getting pretty much the same t-score. I'll write down my calculator t-score. And same p-value, I'll write down the calculator p-value. The big difference between these, though, is my actual degree of freedom is close to 20, and I only assumed it to be 9. So when I said this is a rough estimate, it's not that rough. You'll still end up with ballpark the same p-value, and you'll end up with roughly the same conclusion as well. If your p-value is larger than your alpha, you would fail to reject the null hypothesis, which means in this case, there's no evidence of a difference in average travel distance. When I'm comparing stats versus art. So I failed to reject the null hypothesis because I had a large p-value. I did not have evidence of a difference. I had a t-score of 0.522, 0.523, if I'm being a little bit more careful with my decimals. And I'm getting a p-value of something like 0.607 or so. This was the process going through this thing using a two-sample t-test. I'm going to do the same thing now, but using my ANOVA analysis using an F distribution. So ANOVA, this compares two types of variation. I have my F distribution, and my F will be the mean square of the treatment divided by the mean square of the error, or the variation between my groups, where I'm comparing the centers, divided by the variation within the groups, where I'm comparing those standard errors. Let's start by finding the variation between. This is my mean square of the treatment, and I find this by adding up all of my sample sizes times their averages minus the overall average squared divided by the number of groups minus 1. In this case, this is pretty small data set, so this makes this nice. My first n for statistics, and I can go in either order because I'm adding these things, is 12. The average for statistics is 53.33 repeating, minus my overall average for all of the values was 50.68, and I'm squaring that. For art, this was out of 10 samples. Their average was 47.5. The overall average for all of the numbers was 50.68, and I square that so I don't get a negative. And I'm dividing this by the total number of groups. I have 2 groups minus 1. Well, 2 minus 1 is just 1. So I'm just typing in that top of that fraction there. And I don't know what I'm going to get, but we'll find out here shortly. So I have my 12, 53.333 minus 50.68 squared plus 10, 47.5 minus 50.68 squared. This gives me an MST of 185.58 or so. Let's find the variation within. This is the mean square of my errors. This is my pooled variance. So the way I find my pooled variance is I take each of the individual degrees of freedom, I multiply those degrees of freedom by their standard deviation squared, I add them up, and I divide by the total number of terms minus the number of groups. So for our example, our first degree of freedom, I had a group of 12 that has a DF of 11. Their standard deviation was 27.08, and I square that, so I'm looking at the sum of squares of these standard errors, so the SSE, and I'm going to divide this by my degree of freedom to get my MSE. I had 10 values in my second group, so that DF is 9. Standard deviation 25.19, square it to get a variance. I have 11 and 9, so in total I have 20 for my degree of freedom. Another way to see this, I had 22 terms minus 2 groups. 22 minus 2 gives me 20. I'm going to type this into a calculator and I'll see what I get for my MSE. (11 times 27.08 squared plus 9 times 25.19 squared divided by 20 gives me 688.87 or so. To get my F, I take my mean square of the treatment, the T is on top, T for top is how I remember that, divided by the MSE. So I'm taking this 185.58 and I'm dividing this by 688.87, and this will give me my F ratio. So I'm just going to cheat and take that number divided by that number. My F ratio is 0.269 or so. To look up your F scores, instead of using TCDF, you're going to use FCDF. So this is going to look like p-value, FCDF, whatever your F score is, comma infinity, your first degree of freedom, k minus 1, your second degree of freedom, capital N minus k. So I have FCDF 0.269, comma infinity. My first degree of freedom was this 2 minus 1 number, was 1. My second degree of freedom was 22 minus 2, was this 20. I'm finding this in the same spot that I found my TCDF. So second vars on an 83 or an 84. I'm in F5 in StatList Editor in the TI-89 to find distributions. And in GeoGebra, I'm opening it up, I'm going to probability, and I'm choosing the F distribution. My low value is this 0.269. Upper value is infinity, just a whole bunch of 9s. First degree of freedom was 1. Second degree of freedom was 20. When I did this, this gave me a p-value of 0.610 if I round a little bit. If my p-value conclusion is large compared to an alpha, I would fail to reject the null hypothesis. Now, what I'd like to do is just compare these two things side by side. I have them as two columns here, once with this ANOVA test and once with this TwoSample Ttest. And I just want to show you some of the commonalities between them. First and foremost, my p-values. I will end up with the same p-value for any test. Because you're sampling the same data. So of course you'll have the same p-value. You either have a difference or you don't have the difference. Your p-value is the way that you detect that. My second observation is if I take this t-score, 0.522, and when I'm looking at the F distribution, it has a whole bunch of squares in it. So I'm going to try squaring this number. And let's see what happens when I square my t-score. This gives me 0.27. 0.27 was my F number. So one observation, I'll have the same p-value. My second observation, if you take a t-score and you square it, you'll end up getting your F score. So a good way to double check your work is you can do this process twice and take whatever you get here, square it, and you should end up getting whatever you have here. T squared is F. So when it comes down to it, when you're trying to figure out the best way to study quantitative data, you have options. Are you more comfortable doing the ANOVA process? Or are you more comfortable doing the TwoSample Ttest? ANOVA, I didn't have to use any crazy estimates here. I didn't have to assume I knew what the degree of freedom was, where here I sort of had this lie of the degree of freedom of 9. But it looked like the TwoSample Ttest was a little bit cleaner for me. So I don't think there's a best way, but there might be a best way for you personally as to which one you find to be easier. I'm giving you options.